Hello, here is Jaroslaw speaking. I'm Principal Solution Architect at Red Hat, and in this presentation I would like to introduce you some new features of OpenShift 4 which are important for modernizing existing workloads as well as developing new ones. So OpenShift 4 is based on the Kubernetes as an orchestration engine. In fact, we integrate a lot of different open source projects into a container platform which is enterprise ready and is based on the Kubernetes. So during the productization process, we stabilize, we fix some bugs, we certify with different software and hardware vendors, and then we provide a full support and the life cycle for specific versions. So in order to deploy Kubernetes based container platform, you need to deploy a lot more than just a plain Kubernetes. So Kubernetes itself is a container orchestration engine, and like engine, it is just a part of the full platform. So if we try to compare Kubernetes with the car, the container platform is a car, Kubernetes is an engine. So what you need first of all the infrastructure. Yeah, so you need Linux operating system with the container runtime that will be managed by Kubernetes. You need to plug a networking that will be managed by Kubernetes, and also you need some storage if you want to run some stateful containers in your container platform. You need some tools to install the platform, to upgrade. So Kubernetes is released, the project is released approximately every 3 months. So installing, upgrading automation is a very key feature here. And then once you have the infrastructure running, so you have your Kubernetes as a service running, you need also to deploy some tools for operators, for administrators, to manage, monitor the platform, aggregate, analyze logs, and also for developers to implement and to automate the application lifecycle management processes, starting from CI/CD up to the production deployment. And last but not least, you need to think about the security. So Kubernetes itself defines some security interfaces, some security features, but they need to be implemented in the platform. So, and the Kubernetes itself is just one of the layers. So you need to implement security across all the layers, starting from the operating system where your containers will be running, up to the application containers, where you need to make sure that your code is secure and there are no vulnerabilities that can be used by any attackers. And in OpenShift, we put together all those layers, all those components, and we give you a fully operational car, so the container platform. So looking on the infrastructure side, we have a Kubernetes deployed on top of Red Hat Enterprise Linux CoreOS operating system. Then we have the built-in networking based on the OpenVSwitch. We have possibility to integrate storage. We have built-in monitoring, log aggregation, and many other features. On top of it, we provide the tools and solutions for applications and for developers. So you have different platform services, application services, and the developer services. And in order to be able to manage a large-scale environment, hybrid cloud, multi-cloud, or some edge solutions, we also provide on top the advanced cluster management solution for multi-cluster management. So all those components I'm talking about, they are based on some open source projects or features that we integrate together, we test, stabilize, and put it as a complete container platform, so that you don't have to deal with all those complexities of the infrastructure, but you can focus on building and deploying your applications, which is a real value of the platform here. So the OpenShift container platform has also integrated a lot of containerized software, so that you can easily deploy different Red Hat community and third-party containerized software on top of the platform. So we have some time ago introduced a concept of operators, which are kind of advanced installers, which has a capability to manage the whole life cycle of the application. So not only the installation and upgrade, but also some maintenance, some monitoring, some self-healing. And we have standardized the way how those operators are installed and consumed in OpenShift Container Platform. So the OpenShift architecture is based on the Kubernetes architecture. So we have two types of applications in OpenShift, nodes in OpenShift cluster. So you have the master nodes, which are the control planes of the cluster, and there we have all the cluster management components installed, like etcd database, Kubernetes API, and also some infrastructure services that are deployed across all the cluster nodes, like monitoring, log aggregation, networking. And then we have second type of machines, so workers. So on workers, you can install both the containerized OpenShift components, infrastructure components, like the monitoring stack, the networking, ingress networking, container registry, or the log aggregation, as well as you will install on the worker nodes your own applications. So those workers and masters, this could be either physical or virtual machines, depending on your requirements. And this architecture can be translated into the following deployment architecture. So if you want to have fully highly available cluster without any single point of failure, you will need to install 3 master nodes. So it is important to know that you have to have odd number of masters. Also, you can split your workers into separate groups. So the infra nodes are the workers where OpenShift infrastructure components are deployed. Those I mentioned on the previous slide. So you can deploy a dedicated worker node just to host those infrastructure components, and then your application nodes, as many nodes as you need. Also, you can also deploy as part of the cluster the storage nodes, so OpenShift container storage nodes, which are one of the options available for you to deploy a storage layer, but I will come back to that later on. So OpenShift can be deployed on different public and public cloud, as well as private on-premise environments. So you can see here on 4 major public clouds, we give you a choice between custom managed deployments of OpenShift and managed service deployment, which are provided and maintained by the cloud vendors together with Red Hat. Of course, if you prefer on-premise deployments, you have also many different infrastructure options to choose, starting from the bare metal through the virtualization platform OpenStack, and also different IBM hardware like Z and Power platforms. So OpenShift is offering you a high level of automation in the for the installation process. So we have created a new installer in OpenShift 4, which can automatically install the whole infrastructure. So not only the OpenShift platform itself, but also the operating system. In fact, we have fully integrated and connected together the OpenShift and the Enterprise Linux CoreOS operating system. Moving forward, we have also implemented a full automation for the updates. So the updates in OpenShift 4 are performed in a rolling upgrade fashion. So when you get the notification that the new version is available for your cluster, you kick off the process, and the cluster will automatically deploy new version in a rolling upgrade fashion. So one by one, all the machines in your cluster, without the interruption of the services running and provided by the platform. So if you only have applications that can be spanned across multiple nodes, you can perform updates without the interruption of running your applications. Also, we made a significant investment in the operating system layer. So you have option to use, which is default in OpenShift 4, to deploy OpenShift using the Red Hat Enterprise Linux CoreOS operating system. So the CoreOS is immutable operating system. So it means that you cannot install your own RPM packages on top of it. All additional software needs to be deployed as a containerized workloads. The system itself has been slimmed down just to provide services that are needed to run a containerized workload. So we have a CRI-O container runtime, we have a kubelet for the Kubernetes cluster, we have of course the full configuration of the container tools and the SSH service, and that's all that is needed. So also the updates and upgrades of the operating system are part of the cluster updates, so you don't have to manage and maintain separately the operating system layer here. So in OpenShift it is possible to deploy not only containerized workloads, but also thanks to the OpenShift virtualization feature, you are able to deploy virtual machines on top of OpenShift. So you can use the same concepts that you use and you know from the Kubernetes to deploy and manage and maintain your virtual machines based on the KVM virtualization, and you can use exactly the same tools so that you can have consistent platform for running different workloads, both the containerized and virtual machines. So as part of OpenShift, we also provide default software-defined networking implementation. So the current implementation called OpenShift SDN is based on the Open vSwitch project. We have also released a new generation of the plugin called OVN, which is also based on the same Open vSwitch technology. But also we have an ecosystem of partner solutions that are either already certified or will be soon certified as a part of the OpenShift container platform networking. So the OpenShift SDN and also the new OVN plugin is based on the Open vSwitch. So it implements the VXLAN technology. So in essence, how it works, in general, this will create an overlay network on top of physical network that connects the cluster nodes. So on every node, there will be a virtual switch or bridge installed. And this bridge will manage the communication between the pods running either on the same machines or via the VXLAN encapsulation. It will also communicate pods running on the different nodes, and also using the tunnel, it will also manage the traffic that will go from the pods to the outside of the cluster of the OpenShift cluster. So also additional component, which is also by default installed in OpenShift, is the cluster monitoring. So it is based on the kind of de facto standard solution for monitoring in containerized environments. So the Prometheus as a metric store, Prometheus Alert Manager for creating alerts and sending notifications on them, and Grafana for metrics visualization. So with this solution, out of the box, you have a built-in cluster monitoring, but also you can extend this solution to use to monitor your own applications with the same monitoring infrastructure. So the storage. So we have a lot of options to choose different storage technologies depending really on in which infrastructure you will deploy OpenShift. So if you deploy OpenShift in public cloud, you will have out of the box full integration with the storage which is available in the cloud. If you deploy OpenShift on premise, again, depending on the infrastructure, if you deploy it on top of vSphere or in OpenStack, you will also have automated integration. You can also integrate OpenShift with some storage technologies like NFS, iSCSI, Fiber Channel. And last but not least, we also offer a software-defined storage solution based on Ceph technology called OpenShift Container Storage. So the OpenShift Container Storage is fully containerized storage software-defined storage solution based on the Ceph technology. So you can basically deploy this storage layer as part of your OpenShift cluster, and it will serve as storage to the applications and containers running in your OpenShift cluster. So it can provide the block, file, and object storage. It also supports all storage access modes that are defined in Kubernetes. So read-write once, read-write many, read-only many. So depending on the architecture and requirement of your application, with this OpenShift Container Storage solution, you can meet all the needs that might be defined by the application for the storage. So for the multi-cluster management, we have a dedicated additional add-on called Advanced Cluster Management. So with ACM, you can implement three major use cases. So the first one is multi-cluster lifecycle management, which allows you to create, upgrade, deploy, and monitor different OpenShift clusters on different infrastructures. Then you can implement some governance and compliance solution where you can define some security standards, some configurations, security configuration blueprints for your clusters, and use the ACM to monitor and enforce this configuration across your clusters. And the last major functionality is a solution that allows you to centralize the application lifecycle management, so the deployment of your applications across different clusters using the centralized console. With the ACM, you are able to maintain and manage OpenShift and Kubernetes clusters that could be deployed on different infrastructure, which could be either on-premise or in different public clouds. So depending on your architecture, on your requirements, you might use this tool to centralize the cluster management on different platforms and in hybrid and public clouds. And the security. So it is very important topic in containerized environments because really the container platform is multi-layer solution. So it is very important to have a solution that implements the security across all the layers. And this is how OpenShift is built. So the security starts really from the operating system level, because this is where your containers will be running. So we have implemented and we provide the automated security at the host level, and we leverage the Linux security features like SLinux, seccomp, the control groups and namespaces. Then we have also implemented in the cluster role-based access control, so that every cluster component, for different applications, you can define fine-grained access policies, and they will be enforced using the airbag system. Also in the SDN layer, so in the networking, we have implemented network policies so that you can limit access to the application from the network point of view. Also on the storage level, we have implemented access control, and based on the low-level users and groups permissions, so that you can isolate file systems of different containers from each other. And also we provide for the containerized applications, we provide a full secret management with possibility to encrypt the data at transit and in rest. So this concludes this short presentation about the OpenShift infrastructure. So just to repeat the main value that we bring with the OpenShift. So first of all, it is based on the Kubernetes, includes Kubernetes, but with full security, stability, and reliability. So you have a fully secure and supported Kubernetes platform ready to use in your environment. We provide a consistent user experience across different environments, so you will have exactly the same OpenShift deployment, whether it will be on-premise or in a cloud. We also provide a very rich set of different developer frameworks and tools, which will be topic of my other presentation, and it's all based on the best in the class selection of open source projects and components that we integrate together into fully supported, integrated container platform based on the Kubernetes. So that's all for now. Thank you very much for your attention, and I hope you enjoyed this presentation, and you will watch other presentation I will prepare for you. Thank you and bye.